Today we're going to discuss two problems on rational inequalities. And also, after solving for the value of x, we're going to grab the solution set in a number line. No? So the first problem here, we're asked to solve for the inequality and grab about 2x over x minus 3, which is less than 0. No? For our solution, the first step will be to solve for the critical points. No, how are we going to solve that? No? First, we're going to rewrite this inequality to an equation, and then solve for the value of x. No, for each of the numerator and the denominator. For the numerator, we have here 2x is equal to 0. So the value of x for the numerator is 0. No? And for the denominator, x is minus 3 is equal to 0. So the value of x is equal to 3. So the critical points will be 0 and 3. So if we have this number line here, we will label the critical points 0 and 3. As you can see, the value of 0 here is represented by or marked by a unshaded circle, no? And also the 3 here, no, unshaded. Why? Because it is the inequality states that this is less than 0. No? So we divide this number line here into 3 regions. The first region will be from negative infinity to 0. No? From here, negative infinity up to 0. So for second region, which is region B, will be from 0 to 3. No? And for region C, 3 to positive infinity. So we choose a test point, no? Since we're testing for regions and test points, which is a test point for each region here. So for region A, we choose x is equal to negative 2, somewhere here, x is equal to negative 2. And see if this negative 2 will hold true the inequality given. No? So we substitute the value of x minus 2 to the inequality to x over x minus 3 less than 0. So 2, the value of x is negative 2 over negative 2 minus 3. No? The value of x is negative 2. So we compute for 2 times negative 2 is negative 4. Negative 2 times negative plus negative 3 is negative 5. So we test if that is equal to or less than 0. Negative 4 and negative 5 over negative 5 is equal to 4 over 5. No? So 4 over 5 is greater than 0. So the value of region A will not satisfy the given inequality. So this is false. No? So we don't have any solution for this region here. So we test also for the region B. And we choose another test point which is equal to 1. No? So region B is from 0 to 3. We choose 1. No? And substitute this 1 here to the given inequality. No? So 2x over x minus 3. So 2 times 1 over 1 minus 3. We have here 2 over negative 2. And is that less than 0? Yes, because this one is equal to negative 1, less than 0. So this one is true, no? So we have this region here to be the solution because it satisfies the given inequality. So we have one solution here from 0 to 3, no? Excluding 0 and 3. So we test again for region C, which is 3 to positive infinity. We choose another test point, which is x is equal to 4. And again, substitute 4 here this 4 here to the given inequality. So 2 times 4 over 4 minus 3. So this one is equal to 8. No? And 8 is less than 0. False. So we don't have any solution sets or elements here. So our answer now will be x is greater than 0. So excluding 0 here, but less than 3. So this will be our graph. For our second problem here, we will also ask for the inequality and also graph this inequality here. X minus 3 over x plus 5 is greater than 0. Again, we solve first for the critical points, no? And label those critical points in the number line. For the numerator, we solve for critical points, equate that x minus 3 is equal to 0. And we get x is equal to 3. For the denominator, we also equate x plus 5 is equal to 0. And we're going to get x is equal to negative 5. So our critical points are 3 and negative 5. So we label 3 and negative 5. And also test the regions and test points if that will hold true to the given inequality. So we divide this number line here into 3 regions, region A, B, and C. Region A from negative infinity to negative 5, and region B is from from negative 5 to positive 3. And region C will be from positive 3 to positive infinity. And again, we choose another test point for region A, and we choose negative 7, x is equal to negative 7, and substitute this negative 7 to the given inequality. So negative 7 minus 3 over negative 7 plus 5, and we're going to get negative 10 over negative 2, which is greater than 0. So negative 10 over negative 2 is 5, positive 5, that is greater than 0. So this region here holds true, no? That is true, no? 5 is greater than 0, so this region here will be our solution, no? And test also the region B. Region B is from negative 5 to 3, and we choose x is equal to 1. And we substitute this one here to the given equality. 1 minus 3 over 1 plus 5, so this one is negative 2 over 6, which is negative 1/3, which is greater than 0. That is false, no? So region B will not be included in the solution. And for region C, which is from 3 to positive infinity, we choose x is equal to 10. So 10, substitute 10 to the given inequality, 10 minus 3 over 10 plus 5, that will be 7 over 15, that is greater than 0. So region C is also our solution. So we have 2 solutions here, region A and region C. So the value of x is less than negative 5, and x is greater than 3. So we have these 2 regions here. No? So that's how we are going to solve these inequalities here, including the graphical solution. So thank you again for watching our videos for today. And also, please don't forget to subscribe to our YouTube channel, Bible Friend Tan. And don't forget to subscribe and click the notification bell. And also, if you have any suggestions and comments, please don't hesitate to send us your messages and solutions and comments, and so that we can improve our way of presentation. So thank you, and see you again later.